This segment discusses a fascinating star, the 10th brightest in the night sky. Its name, though challenging to pronounce, may be familiar to some. Recent observations indicate it has become 50% brighter, aligning with the discovery that the universe is expanding. In 1929, scientists learned that our bodies consist of elements formed in the cores of stars. By 1957, it became clear that the night sky wasn't just beautiful but showcased the immense forces of the universe. There's so much complexity that much of what happens in space remains a mystery to us. Why do stars and planets exist? What other possibilities might there have been? Often, we ignore phenomena until they reach a critical point, even when they could directly impact us. This scenario seems to be unfolding again with Betelgeuse, historically one of the largest and most prominent stars, now exhibiting alarming activity. This red supergiant star has been quaking violently, suggesting something extraordinary is taking place. It's one of the largest stars known, with a mass approximately 20 times greater than our Sun, making our Sun seem insignificant by comparison. Though Betelgeuse may appear as just another distant star from Earth, it holds a far superior status, located more than 640 light-years away, a vast distance in cosmic terms. Even if faster-than-light travel were possible, it would still take over 640 years to reach Betelgeuse. Under normal circumstances, a journey there would span over 12 million years, far exceeding the entirety of human history on Earth. Despite its incredible size, Betelgeuse has always been relatively stable. However, it has recently entered a period of intense activity, with scientists unsure of the exact cause. Betelgeuse has long been considered a pulsing red supergiant, constantly fluctuating in size and brightness. These variations occur over cycles lasting from 10 to several hundred days. Its brightness can swing dramatically between magnitudes, ranging from a dimmer plus 0.5 to a brighter 0, marking one of the most significant changes for a star. These fluctuations occur in regular cycles, with the shortest being about 185 days and the longest lasting over 2,300 days. What's particularly intriguing is the recent significant dimming of Betelgeuse, noted in February 2021 when its V-band magnitude reached plus 1.614, one of the lowest levels in years. This dimming strayed from the star's typical pattern, signaling an unusual event. The star's bright red hue is due to its cooler surface temperature of around 3,500 Kelvin, compared to the Sun's 5,500 Kelvin. Despite its cooler temperature, Betelgeuse's massive size means it emits more energy overall, though its lower surface temperature causes it to appear dimmer. Betelgeuse has maintained relative stability as a pulsing giant, but what has caused its recent shift from tranquility to turmoil? Some speculate that it may be due to the star's gas shell undergoing rapid changes. Betelgeuse is slowly exhausting the hydrogen in its core through nuclear fusion, converting it into helium. As hydrogen fusion wanes, the outer layers expand, signaling the transition into the red giant phase. During this phase, the core accumulates helium, initiating helium shell burning, a more chaotic process compared to hydrogen fusion. This stage generates significant energy, causing the outer layers to expand and contract, resulting in the star's pulsations. Helium shell burning produces intense stellar winds, which strip mass from the star's outer layers. These winds can significantly alter the star's evolution by redistributing matter and energy. This dynamic process causes Betelgeuse to swell and shrink, creating the pulsations that change its brightness over time, akin to the star's heartbeat. To fully understand Betelgeuse's behavior, scientists use techniques like photometry and spectroscopy. Photometry measures changes in brightness, while spectroscopy analyzes light to reveal information about the star's temperature and composition. As Betelgeuse pulses, its spectral lines shift and broaden, revealing conditions in its outer layers. By combining these methods, astronomers can piece together a more comprehensive picture of the star's internal processes. Astrophysicists also employ computer models to simulate the complex dynamics within Betelgeuse. These models incorporate factors such as nuclear reactions and fluid dynamics, helping scientists predict how the star will evolve. Stellar convection, the process by which energy moves from the core to the outer layers, plays a key role in shaping the star's pulsations. As hot material rises to the surface and cool material sinks, convection currents drive changes in brightness. Alternatively, Betelgeuse's pulsations could be influenced by external factors. In binary star systems, the transfer of matter between two stars can trigger pulsations. As material flows from one star to another, the receiving star undergoes structural changes, which may disrupt its balance and lead to pulsations. Historically, stars were studied as isolated objects, even supergiants like Betelgeuse. However, the interactions between stars in binary systems are now recognized as critical to understanding their behavior. In Betelgeuse's case, the cause of its recent activity might be more than just internal processes. It could be on the verge of a supernova, a catastrophic event that would result in the star's explosive destruction. As a massive star nearing the end of its life cycle, Betelgeuse is in a delicate balance between the inward pull of gravity and the outward pressure from nuclear fusion. Over time, as it consumes its nuclear fuel, this balance shifts. With less hydrogen available for fusion, the core contracts under the force of gravity, causing the temperature to rise. Eventually, the core becomes hot enough to fuse heavier elements like helium and carbon, marking a more advanced stage in the star's evolution. However, the formation of an iron core within Betelgeuse signals the end of its life cycle. Iron does not produce energy through fusion, disrupting the balance between gravity and nuclear reactions. When the core collapses under gravity, it triggers a supernova explosion. The outer layers of Betelgeuse would be violently ejected, sending shockwaves and light bursts throughout the cosmos, leaving an extraordinary spectacle for observers on Earth. This impending event represents a pivotal moment in the star's life and may hold profound implications for our understanding of stellar evolution and cosmic phenomena. Let me rephrase this content for you with different wording while maintaining the same message. We're talking about one of the brightest stars in the night sky, ranking as the 10th most luminous. Its name is a bit tricky to pronounce, so I'll skip trying to say it out loud, but you might give it a shot. Recently, it's increased its brightness by 50%, and that's pretty remarkable considering the ever-expanding nature of the universe. In 1929, scientists discovered that the elements composing our bodies were actually formed in the cores of stars, and by 1957, we realized the sky wasn't just a pretty sight, it reveals the incredible power of the cosmos. There's so much happening in the universe that we often have no idea what's truly going on. We ponder deep questions like why we exist or why stars and planets even form. But typically, we don't pay close attention to things until they start posing a real danger to us, and that might be happening now with Betelgeuse, a massive star that has begun exhibiting strange and concerning behavior. Betelgeuse has always stood out as one of the largest stars visible to us, but lately, it has started to tremble intensely, indicating that something significant is occurring. In this exploration, we'll dive deep into what's going on with Betelgeuse and how it might impact